our problem asks us first to find the position equation for the baseball helmet. We have that S of t equals minus 16 t squared plus 90t plus 700. This is our first position equation.
So now we have to find the velocity equation for the baseball helmet using definition with limits. So now that we have our position equation, we have to derivate in order to have the velocity equation. So this one, we just apply the definition, that t plus h over all the equation over h. So now we solve. We see now that we have a binomial square, so we solve it. And everything minus the primitive function f of x. So now we just solve the binomial, we simplify all the terms, and now we have this. So as we can see, we have all the terms in the numerator have h, so we just simplify, and now we have this as the first result.
Now the problem asks us to explain you the meaning of the obtained velocity. So this first derivative is s prime t. That's the same of the velocity function. That means that is minus 16, no, minus 32, sorry, 32t plus 90. So this is our first derivative, our velocity function. This helps us to determine the velocity in any time, like we're going to do right now. The next thing that our problem asks us to do is to calculate the value of the maximum position of the baseball helmet. So the maximum position, when the ball is thrown and its maximum position is here, that's when the velocity is 0, because it's reached its maximum point. So I'll erase this. We'll use this velocity equation. We equal it to 0, and we have minus 32 t plus 90. This is 32 t equals 90. T equals 90 over 32. Time is 2.815 seconds. So, to calculate the value of the maximum position of the baseball helmet, we got time from the velocity function when it was 0. So with the time we have, we substitute now in the position function with this time, and we got that the maximum position the helmet will have is 826.5625 feet.
Now the project asks us what is the velocity of the impact when the helmet reaches 0 feet, the minimum position. So we have the velocity position and we equal it to 0. So now what we have to do is to make the quadratic formula, because we have two variables here that we cannot solve in other ways. So we just see which terms we have and we apply them on the quadratic formula. So here's go a, b, 4 times a times c times 2 times a. So now we just solve everything and we got this. And because it's a square root, we have two values. We just take the positive one because there's no negative time. It takes 10 seconds to reach the minimum position. They ask us is not the time it takes to reach the minimum point, that it's 10 seconds that it takes. What they ask us is the velocity. So we just take the 10 seconds and we substitute that value on the velocity function which we already had. So we just substitute and solve, and the final answer for the velocity that it takes to take the ground, it's minus 230 feet per second.
So now the problem asks us to calculate the value of the acceleration. The value of the acceleration is the second derivative from the position function, or the first derivative from the velocity function. So this is equal to minus 32. The problem asks us that when there's 2 seconds, what's the acceleration? But the acceleration will never change because the acceleration is a constant, and even though the time is 2 seconds, the acceleration will always be minus 32 feet over seconds.
They ask us if the helmet will still be in one piece after it hits the ground. And yes, it's going to be in one piece after it hits because it's like a football helmet. It can resist more than 7,000 newtons. Thanks for watching. This was our project video of Roberto and Sergio.